Today is March 4th, 2025, and my guest is author, naturalist, and scientist Matt Ridley. This is Matt's fifth appearance on EconTalk. He was last here in August of 2020, discussing innovation, which was voted the third best episode of that year by listeners. His latest book, and our topic for today, is birds, sex, and beauty. I want to alert those listening with young children. We may get into adult topics in this conversation. Matt, welcome to EconTalk.
Thank you. My ambition is to get to second best talk of the year.
Okay, yeah, move up. This is quite an extraordinary book. You alternate your own extensive observations about birds, their mating behavior, with an incredibly thorough history of how we've thought about such matters since Darwin. And you have multiple goals in the book to understand the, quote, extravagant sexual display of birds, to rescue Darwin's focus on sexual selection, and equally to convey a sense of wonder about the natural world, and in particular, the rather extraordinary behavior of the black grouse. So I want to start with a distinction that's at the heart of the book and runs all the way through it, which is the difference between natural and sexual selection.
Well, natural selection, the main mechanism of evolution, is known as survival of the fittest. If you're strong enough to cope with bad weather or diseases or something, then you're more likely to survive, and that means you're more likely to be a parent of the next generation. Sexual selection means seduction of the hottest, to put it at its sort of most glib. And what that means is that the way you're going to get to be a parent of the next generation is by seducing a member of the opposite sex. And when that's competitive, as it is in many species, it can be that the way you get to seduce a member of the opposite sex involves reducing your chances of surviving. Growing a fancy tail, being very conspicuous, doing a lot of singing, a lot of dancing, exhausting yourself. These kind of things are what a lot of birds do when they prepare for mating. And that actually hurts their chances of survival, but increases their chances of getting a mate and therefore passing on genes to the next generation. Now, the distinction between these two has been seen quite often as a minor one. One is really just a version of the other, and it's just that the female is choosing the sexiest male or vice versa, and that enables her to get the best genes. So it's really just survival of the fittest at one remove. But Darwin didn't think that, and I don't think that. I think it's a very different process with very different results. I call it the fun version of evolution because it's capable of producing bright colors, loud songs, extensive plumage, crests and plumes and long tails and things, sort of creative stuff, which doesn't necessarily mean anything. It doesn't necessarily mean that your kids are going to survive better. It might just mean that they're going to seduce better. And once you start thinking like that, it becomes a sort of really intriguing rabbit hole to go down.
Yeah, the book is that rabbit hole. It's quite fascinating, and we'll talk in a minute about your personal experience sitting in the dark as before dawn, watching birds prepare to dance and flutter and sneeze and do all kinds of things. But locate us in the historical debate over this with Darwin and his contemporary Alfred Russel Wallace. They both get some intellectual credit for discovering evolution and natural selection. Darwin gets, I'd say, just a titch more than poor Alfred Russel Wallace. And then after Darwin dies, you talk about how Alfred Russel Wallace denigrated consistently Darwin's ideas about sexual selection. And I have to say that when you gave that little overview of something about what doesn't have to mean that much about, it could just be the selection of, it's like, whoa. Because as an evolutionary scientist, that's dangerous talk. What do you mean it doesn't have to mean? I mean, isn't it all about how many genes get passed along? The idea that there could be something fun or just beautiful, which is a huge focus of this book, is makes many people uneasy. We want a cause, we want an explanation. So start with Wallace and Darwin, and then talk a little bit about that question of beauty.
Yeah, and it's this question of whether or not there's any rhyme or reason behind some of the colors and songs of birds that we'll get to. But yeah, let me start with Darwin. Even before he wrote The Origin of Species, he was saying, I need to understand beauty. There's a lot of beauty in the natural world, and I don't think it was put there to please us, which was essentially the theological version of evolution that he's up against. I think it was there, he says, to please the opposite sex, and that in itself is a form of evolution. So there's a wonderful quote from The Descent of Man, which was his 1871 book, where he says, the most refined beauty may serve as a sexual charm and for no other purpose. And so what he's saying is that when, and he actually draws a rather wonderful parallel with a friend of his called Sir John Seabright, who was breeding bantams. And he says, if a man can in short time give elegant carriage and beauty to his bantams, according to his standard of beauty, I can see no reason to doubt that female birds, by selecting during thousands of generations the most melodious or beautiful males, according to their standard of beauty, might produce a marked effect. So this is Darwin's hypothesis. That's actually a quote from The Origin of Species, his great book. He then returns to the topic at great length in The Descent of Man in 1871. And he finds that he persuades very few people of this, that females choosing gorgeous males is a major force of evolution. Nobody goes with that.
And you have to remind listeners that in the bird world, which is what we're going to focus on today, it's the males who are glossy and colorful and glamorous, and the females are drab. So that's what when you talk about that, the sexiest male, that's the issue.
That's right. And I'm not being sexist. I'm merely pointing out that in birds, it's nearly always the male that's brightest. Not always, actually. There's a small minority of species where females are more brightly colored and more active in courtship than males. And that's an interesting topic in itself. But yes, the peacock's tail was the classic example. And the one they ended up arguing about, Darwin and his rival Alfred Russel Wallace, was a bird called the Argus pheasant, which has three-dimensional optical illusions on its wing feathers. Now, Wallace and a number of other people said, look, come on, this is not trying to please the bird. What on earth could the purpose be of a female bird being capable of seeing three-dimensional optical illusions? Give us a break. That's something that we artists who've been to Oxford appreciate. There's a degree of that sort of snobbery going on. So Darwin and Wallace had a very interesting relationship. They discovered evolution by natural selection independently. Darwin had been hesitating to publish for 20 years. So when Wallace wrote to him and said, I've got this idea, and he realized it was exactly the same idea, it was a bit of a difficult moment for Darwin. They ended up announcing their idea together at the Linnaean Society in a way that gave Darwin most credit. So Wallace behaved pretty well in accepting that he's the also-ran in the story. But Darwin had been working on it for longer and thought about it more deeply. But when it came to The Descent of Man, the book about sexual selection, and in the run-up to publishing it, Darwin and Wallace had this big disagreement about the role of sexual selection. Darwin wants to devote a whole book to this topic. Why beauty? And are females, by selecting gorgeous males, driving evolution? Is it actually a sort of directed form of evolution? And Wallace says, no, I just don't agree. And they had a summit, a weekend, when they got together at Darwin's house in Kent in September 1868 to hammer out their differences on this topic. And they didn't do so. They didn't agree. They were still at loggerheads afterwards. And Wallace says, look, the reason males are brightly coloured is so that the female can recognise the species. Well, that's a bit weird. Brown birds seem to find their own species pretty well. Or he says the reason is because, well, yes, she wants the most beautiful male, but that's because he's the strongest. So she's going to get, she's going to have strong kids, strong children, offspring. So it's really just another form of natural selection. And Darwin disagrees. He says, no, I think they're interested in beauty for its own sake. And none of his usual defenders came to his defense on this topic. So Thomas Henry Huxley, Darwin's so-called bulldog, never really mentioned sexual selection. He's clearly embarrassed by it. He thinks Darwin's gone off the reservation on this one. Herbert Spencer, likewise. So by the time Darwin dies, he has lost this battle. Nobody thinks that the reason a peacock has a tail like it does is because peahens like beautiful males. It's that simple, as it were. And by then, Wallace has fallen back on a different explanation for things like peacock's tails, which is really pretty bizarre. He just says, look, males have more energy, so they need to grow longer feathers to waste this energy. Well, the premise is just not true. Males don't have more energy than females. It's a sort of ridiculous idea. But throughout the 20th century, the Wallace version, where females are choosing brightly coloured males because that way they get good genes for their offspring to survive, becomes the dominant theory. And there are at least two attempts to go back to Darwin's idea, which essentially fail, which get ignored. And I'm sort of saying that currently, and it's not just me, but people like Richard Prum at Yale, who's written a wonderful book called The Evolution of Beauty, are saying, let's have a fourth go at persuading the biological world that Darwin was right here, that beauty is something that birds appreciate for their own sake, for a particular reason that I can explain in a minute.
So I want to, in a little bit, I want to come back to this fundamental foundational difference, because I think it actually illustrates something quite interesting in the field of economics. But to get there, we're going to have to talk about Ronald Fisher, and we'll get there, the statistician. But I want to just summarize this for listeners hearing it for the first time, because the word selection is in both these terms, natural and sexual selection. And I think it was hard for me when I first started reading the book to keep them straight. But I read the book, so I think I've got it. But for those who are hearing it for the first time, the argument, first of all, the Darwin argument seems absurd. I'm sorry. He's a great man, great thinker, but the idea that birds have an aesthetic sense and are willing to sacrifice their genetic fitness of their offspring to produce offspring is hard to understand, given the size of the bird of the brain, and there's no bird culture. There's no magazines of, teenage peacocks are not reading magazines with pictures of peahens are not reading magazines with pictures of peacocks' long tails and getting excited about it. It's hard to understand this aesthetic thing when a bird has a brain. We call it a bird brain, meaning small, the size of a pea or a walnut. So I understand the challenge. And then this variation of Wallace's is that it's okay to prefer gaudy males because you'll produce gaudy offspring and females of the future will like them. And even though it is a handicap, you could still win the genetic lottery that way. And then there's one other flavor, and tell me if I'm getting this right. So that's one argument, and that's going to be more like Ronald Fisher's argument.
Well, that's really Fisher. Wallace doesn't really say the key is to have offspring who are good at getting mates. He says the key is to have offspring that are good at surviving.
Right. So there, the claim, and I read these kind of articles 50 years ago when I was young and foolish. I always thought the claim was, and you talk about it, is that it's, and you actually use the quote, with a name like Smucker's, it must be good jam, a line that crossed my mind about 3 paragraphs before he used it, because, it's saying, I'm so fit that I can have a long tail and I can be brightly colored and be conspicuous to predators, so pursue me. So this, and again, listeners who are economists will start thinking about, this is like signaling. This is a signal. I'm providing a costly signal to show that I'm so skilled, I'm so fit that I can even overcome this. And therefore, the females find me attractive. So that claim, is that Wallace's claim?
Sort of.
Or his followers?
Sort of. It's a man named Amot Zahavi, an Israeli scientist in the 1970s, who turns Wallace's claim into that strong a version when he does his so-called handicap theory. And he's saying it's the very fact that you've survived despite having a long tail that proves you've got good genes. And that's what the females are after. The fact that you're handicapped, but nonetheless successful in surviving. The problem with that is that, there's, well, why not have one eye or one leg or, why not be completely sort of, crippled, and so that you can't live at all.
I can't fly. Choose me.
Exactly. And of course, the sort of more sophisticated versions of the handicap theory say that, look, this bird is successful despite its handicap. No, that's wrong. This bird has managed to seduce lots of females. It's successful because of its handicap. That's if you want to call it a handicap, the tail. Do you see what I mean? So to the extent you can, you turn this into a signaling of your fitness, your ability to survive. You're essentially well, you can see the dilemmas you get into here, and
the obvious other one is, why wouldn't you pick an extraordinary achievement that actually increases your fitness rather than reduces it? A longer claw, sharper talons, fill in the blank. Things that are obviously correlated and produce more offspring because your kids have those things. That should be, it's weird. These are bizarre.
And actually, when you think about it, that does happen in quite a lot of non-gaudy species, such as mammals, where the biggest, strongest elephant seal gets to mate with the females, and she says, fine, that's good, I'm going to get big, strong genes for my offspring. But there's no need for him to be beautiful. In fact, elephant seals are the very opposite of beautiful, to our eyes at least. The point is that these peacocks and black grouse and birds of paradise, they're not being big and strong, and they're not even really fighting. There is a lot of fighting goes on, but it's not a sort of conquest to the death where one drives out all the others and then monopolizes the females. It's a competitive display. And they're not necessarily very big, these males. So again, it's getting at the fact that there is some value in being beautiful or colorful or tuneful or whatever it is that's being exaggerated. There's some reward for exaggerating a feature of display. Now, what could that be? And as you hinted, I think the best answer essentially comes from Ronald Fisher, and then turned into good mathematical models by Russell Landy and Mark Kirkpatrick in 1980. And Fisher develops his theory in 1930. And what Fisher says is that if you think about it, if the females are all using the same criterion of what's beautiful, then it's vital that you, as an individual female, go along with that fashion, because otherwise you might have a son that doesn't get to mate. You need to have a sexy son. And the best way to do that is to make sure that you're using the same criteria as other females. So they're going to have a preference that's going to evolve towards, in some arbitrary direction, some random direction. And the preference and the trait are going to co-evolve together. And so Fisher put it rather neatly, actually, in a quote, which I can find for you, where he says, my theory is that tasteful hens, that is to say hens that have a criterion for what's beautiful, tasteful hens don't rear more chicks, but their sons are finer and therefore get more grandchicks. So it's this sexy son hypothesis that gives Darwin a reason for his observation that usually females, but certainly one sex, is interested in how beautiful the other sex looks. Because Darwin didn't have a reason for why this might be. He was just saying, look, it looks like that's what's driving it. And Fisher comes along and says, here's why. Because once a species starts being selective in one sex, then it's going to run away. It's going to be a vicious circle. It's going to be the more the females are selective, the more the males are going to evolve a flamboyant trait. The more flamboyant the trait, the more the females are going to be selective. And it doesn't matter. The tail isn't signaling anything. It isn't saying you're the strongest or the best. It's just saying you're the best at seducing, so it's a completely circular argument in a way.
Yeah, and as an economist, I find it amusing because listeners, I challenge you to maybe pause for a second and think about what Fisher's theory might remind you of in economics. There are two things that come to mind. One is Keynes's idea of a beauty contest. The stock market is a beauty contest. He says, you don't really have to pick the best stock. You just have to pick the stock that everybody else thinks is the best stock. So if you're trying to decide who's going to win the beauty contest, you don't have to figure out who's the most beautiful woman. You have to figure out who other people will think is the most beautiful woman, and that's what stock picking is. And of course, he's onto something, but he's missing something really important, which is there comes a reckoning in the stock market, which is if the stock doesn't have intrinsic value, even though everyone thinks it does, it's very hard for that to persist. And eventually, fundamentals come and knock that stock down to the point where most people would say that's true in speculative frenzies and in other strange irrational exuberance, but it's not a great model for how the stock market actually works over time, or the role it plays in a capitalist system.
Right.
And similarly,
can I just interject there, because I love that example, and actually I remember 20 years ago a stockbroker friend calling me and saying, you really should buy British biotech. They've got a cure for cancer. And I said, really? It doesn't sound very likely. And what I should have said was, is that what you're telling all your clients?
At least for a while.
British biotech's price went shooting up for a while, and then, of course, it crashed. Now, what's the equivalent of the crash in birds? It's just possible that some of these species get to the point where they really have made themselves so crazy that it's hard for the species to continue to survive in the wild. The example people used to use was the giant elk, which had these enormous antlers and couldn't fit between the trees when it was being chased by hunter-gatherers. Nobody believes that particular version of that theory. But it's not impossible that some of these birds of paradise and other things are more likely to go extinct than if they had stayed brown and skulking in the undergrowth.
Yeah, and this so-called sexy sun theory of Fisher's just seems to ignore the fundamentals in the same way that the beauty contest metaphor of the stock market does. You'd think it would also matter. And again, I would just emphasize that why not pick something that's why would an equilibrium emerge where a destructive trait is what people think is is sexually attractive rather than a helpful trait. And I think, and Fisher was agnostic on that, right? He wasn't doing the Zahavi theory that it's showing you how strong you are. And it's also a little weird that it's birds always, mostly, right? It's which is also a bit of a puzzle. But the other part of this that reminds me of economics,
I'll come back to that point about why it might be birds. But yeah, go on. Yeah.
So the other thing that reminds me of economics, and when we finish this, I want to make sure we get to the grouse. That'll be next. I'll let you respond, and then I want to get to your personal experiences, but because they're fascinating, and the grouse itself is incredible. I know all our listeners are on the edge of their seat, but it would also remind, and they should be. You should be, because I promise you, it's going to be interesting. But the other economics thing it reminds me of is this idea you can get stuck in a bad equilibrium. There can be sort of these fixed costs, and then before you know it, you're stuck in an inefficient equilibrium, and it rules out the possibility of innovation, overcoming the bad, the first mover advantage. It's a bad technology, so fine, go invest in the new, better technology, and to argue that the inferior technology persists because these changeover costs, it's possible, and it is mathematically possible, but it doesn't, for me, again, I'm a kind of a competitive market-oriented guy, I find it a little bit analogous and a little bit troubling that the power of the natural selection part doesn't start to really weigh in here and shoot and destroy these innovations that are gaudy, destructive for the bird because of predators, but are attractive to the female. You'd think you'd want females who are attracted to safer things, and that innovation would overcome, et cetera, et cetera. So it just reminds me of a lot of those theories of innovation that I think are usually wrong. And
so
I think been proven wrong.
Would an example of that be VHS versus Betamax or whatever it was? Exactly.
People said Betamax was better, but VHS dominated because they moved first. And then when people looked more closely, it turns out it's not so obvious it's better. The same thing with the keyboard, the so-called QWERTY keyboard, and that obviously it was a better keyboard, and it was but somehow everybody got stuck using this horrible keyboard when actually it's not that hard to learn a different way to type if it's X% faster. Stan Leibowitz and others wrote some nice papers showing that the facts don't necessarily support these.
Right.
You get stuck in this bad equilibrium.
Yeah. And actually, I can think of another couple of economic analogies, and you can tell me whether these are helpful or not. One is I was listening to Johnny Ive on the radio last week, and he was being asked about how he came up with the idea that the iMac should be blue and slightly translucent rather than grey.
Johnny Ive being the engineer at Apple, very important.
Being the chief designer at Apple. I remember vividly the first time I saw an iMac, well, maybe not the first time, but I remember the feeling of seeing an iMac for the first time and thinking, oh, so computers don't have to be grey and utilitarian. They can try to be beautiful. And now, I'm speaking to you on a MacBook Air, which is my favorite product of the modern era in terms of design. I just think when I first saw one of those, I thought, this is a beautiful thing. This is well done. So the role of attractiveness is important in economics as well as utilitarianism. And the other theory, of course, that we can think of here is Thorsten Veblen's conspicuous consumption point, that the purpose of buying a red sports car for several $100,000 is, which is a waste of money and a cost to you, is to show that you can spend a lot of money, which is the kind of handicap theory version, or it's simply because that's the way the fashion has gone. So these are very similar arguments. And there is no doubt that human beings, we can get to this at the end if you like, are a sexually selected species in some sense. We have selective mating by both sexes, by the way. And sure. I describe how there are certain birds where both sexes are selecting the other. So, just because there's, both sexes are selective doesn't mean you don't get sexual selection. It means you get two-way sexual selection. And I personally think that we've underestimated the importance of mate choice as a driving force in human evolution. But we can come back to that, Russ, because you wanted to move on to birds.
Yeah, and the last thing I just want to say about this signaling thing is that, the primitive forms of signaling theory and education are that the purpose of college is to show that you can endure 4 years of tedious exercises. It's not to actually learn something, and that's a bit of a parody of the signaling theory, but it's close to what it says. You're showing your persistence and your Sitzfleisch and your grit. But my view is, why not demonstrate that learning something valuable at the same time? So I have a little bit of unease with the Fisher story, but I want to get to the black grouse, and I want you to summarize. It's not easy. Summarize their peculiar behavior in what is called a lek, L-E-K, a lek, which is a bird thing. So talk about what a lek is and how the black grouse leks. It's a verb too.
Right. Well, the word lek is Swedish for play, and it's also sort of an old English word as well. Lakan is the same root. And it's come to be the word that describes biological species in which a group of one sex gathers in one place predictably to competitively display two members of the opposite sex. And this is a habit that's particularly conspicuous among certain birds. So there's a few dozen birds that do this lekking behavior. Several of them are in the grouse, several of them in the birds of paradise, the manakins, a number of other species do this. The black grouse, which I studied, or I watched for several years and still do, they live in Northern Europe, across into Asia, Northern Britain, and they are the female is brown and mottled, and the male is black, with a bright blue neck and bright red combs on top of his head and bright white spots on his wings and a lyre-shaped tail that spreads out either side in a sort of bow, and a great big white feathery bottom behind the tail that stands up vertically. So he's screaming, "Look at me," in his plumage. Now, every dawn from about October through to about June, the adult male black grouse will gather in one spot, and that spot is predictable. It's the same every day of the year. It's the same every year. So, I'm going to go tomorrow, actually. I'm going to go and check how they're getting on at one of the spots. And as long as you're there an hour before dawn till an hour after dawn, you will see a dozen or 20, sometimes even more, males gathered together in this one spot. Now, that's very unusual in wildlife. Wildlife is often unpredictable. You don't know exactly where you're going to find it on any particular day at any particular time. But these creatures, some of these sites have had displaying males on them at dawn for decades, if not centuries. And the same is true of the sage grouse in North America, by the way, which has even bigger leks, where you get up to 200 males sometimes on the same sites. And you know exactly
and to be clear, this is not the entire black grouse population. There's multiple leks across England, Scandinavia, and elsewhere, but the same team shows up at this one spot. Carry on.
That's correct.
So a group of a subset.
Yeah. So there are many leks, but any one lek in the black grouse has, as I say, between 10 and 30 males usually on it, and it's the same males every day, and each male has his designated spot on the lek. So the whole lek is about the size, I call it the size of a tennis court. That's a very rough thing, but it gives you an idea. You've got 10 or 20 males fitted into the size of a tennis court. The ones on the outside can have quite big territories. They wander around quite a bit. The ones in the middle have tiny territories, just a few paces across. But the closer you are to the middle, the more likely you are to end up mating. The more senior and successful you are, But what's so bizarre about it is that these are colleagues, these are comrades. When they leave the lek, they often leave together and feed in a flock. They're chums. And then when they come back to the lek, they behave with terror if they're in someone else's little territory, and they run through with their tail folded and their head down to get to their own territory. And then when they get to their own territory, they turn around, spread out the tail, swell up the eye combs and say, right, no, you dare attack me on my little spot. So there's this strange, each bird's home is his castle sort of aspect to it, which, by the way, the nature documentaries get wrong, I think, and I make this point in the book, that they talk about these fights that you see on the lek resulting in one winning and the other leaving, and the winner then dominates the females or whatever. And this is a mammal way of looking at it. That's all wrong. And that's the way stags and seals do it, but it's not the way birds do it. The fights nearly always end in stalemates. They're still there. The neighbor is still next to him. It's only a few paces away. And then what's thrilling, of course, towards the middle of April onwards, this is when the females start visiting the leks. And they'll visit for several days each, mate once, usually only once, but that gets them enough sperm to lay a whole clutch of eggs. And so what happens when the females arrive? And like a guy who I write about in the book called Edmund Selous, who visited leks 100 years ago, what really strikes me is how the females are in charge of their own decision as to who to mate with. And I took a female primatologist to watch the lek one time last year, actually, and she was amazed. She said, if this was chimpanzees or bonobos or anything, or gorillas, females don't wander around checking out different males in mammals. They get harassed, they get molested, they get jumped on. But these females, they wander through the lek. Each male that they pass displays frantically to them, but doesn't try and jump on top of them. And finally, when she's ready to mate, she will squat in the territory of the male she's chosen and spread her wings slightly. And she'll usually do this several times, and at the last minute, she'll jump away, saying, I'm still not quite sure. I'm being a bit anthropomorphic there, but you get the point. And finally, she will let him mount her. The moment he mounts her, the neighboring males rush at him and try and knock him off. But it's all over so quickly, in a couple of seconds, that doesn't usually prevent him mating. She then flies away within a minute or two and probably never comes back to the lek for another year. And of course, the point is that on the lek I watched, there was a male called Black Spot who had one black spot on his white feathers that enabled me to recognize him. And he got all but one of the matings 1 year on the lek, the year that I described. So these females are all choosing the same male. Now, to you and me, it's very hard to tell the difference between them. He looks a little bit more vigorous. His display is a little bit better. His crooning noises are a little bit better. But, maybe they're just copying each other. Maybe they're just saying, right, let's agree that this is the chap we mate with this year.
So there's a few things that just want to clarify because they're so extraordinary. You said that starts in October?
Yes.
The lek. So they show up every day, but there's no women.
There's no women for months on
end.
And
they still go to their spot. They dance, right? They make the noises. They flutter the wings. They stick up the rear end.
No, to be fair, there is a lot less action in October, November, January, December, January, February. I visited the lek a few weeks ago in February, and there was a little bit of roo-cooing and sneezing noises. And there were a couple of fights. But maybe because it was a howling gale and pouring rain, they mostly just sat there looking at each other. So it's much quieter.
Show up.
They show up. At dawn.
The females aren't there.
There's no food there. So they have to, this is an expensive waste of time for them in terms of their survival. And they've got to spend the rest of the day going off and finding food somewhere. And they'll come back sometimes in the evening, not always. They're less reliable in the evening. But it's this period, an hour before dawn to an hour after dawn, for months on end, they're there. Now, you will occasionally get weather so bad that they won't turn up in January or February. They're so desperate to get food that they're off looking for berries in the bushes or something, and there's too much snow or something like that. So it's not, but by the time you get into April, they are there every morning, they're displaying, and there's a crescendo of activity towards this golden. Females generally appear between 20 minutes before sunrise and 20 minutes after.
But this entire, let's call it cultural extravaganza, this festival on the hilltop, and it's not the top, and it's nothing special about the physical place. You said it's sort of flat, but not super flat.
Yeah.
But this location, which lasts for months, has a 20-second culmination of the mating, and almost all, sometimes all, but still sometimes almost all of the males who've been working hard since October and preening and doing their thing in the time, those 4 days when the females show up, they get bupkis. They get nothing.
Yep.
They don't mate. Coming back to our question about sexual selection, they don't pass their genes on. It is really, black spot is the alpha male, even though has not conquered all the other males. It's not what it's about. And does not apparently have the fitness that's any really different than the other 20 birds out there.
Well, so I rely heavily in my book on a long standing study that's been going on in Finland for many, many years now, where they do measure the birds, they weigh them, they measure various features of their plumage, their color, the length of their tail, et cetera, and they stake out the leks with, markers so that you can tell exactly what's going on, and they have gathered evidence on what it is that causes a male to succeed, and there's a pattern. They tend to display more, the successful males. They sort of have a longer tail. They usually have brighter red combs. The blue feathers on their neck are usually a bit more blue, etc. But it's not a very strong pattern. And of course, there's a paradox here, which is that the more selective the females are, the less variety there's going to be in the males, because most of the males are going to be sort of half-brothers or first cousins. So you're actually going to be driving down the genetic variety in the population by having this extreme mating skew, where one male gets to father most of the offspring in one area. The males, by the way, stay near where they were born. The females don't. They move a long way away. So you've got, you've not got a really bad inbreeding problem, but you have got this lek paradox that the species that is most choosy about which male to mate with is the one that has the least genetic reason to be choosy. And again, that's a sort of clue.
Explain. Why?
Well,
say that again.
Because in a species where each female mates with a separate male, then let's say in an imaginary population of 20 males, all 20 are going to get to father offspring. But in the black grouse, only one of the 20 is going to father the offspring in an area. And so all the offspring are going to be half-brothers or brothers. It's not quite that clear-cut, but it's roughly like that. And therefore, there's less genetic variation generation after generation.
Right, okay.
In a species where there's this much selectivity going on. And by the way, one of the things the Finns discovered, the Finnish study discovered, was that the male who succeeds and manages to get nearly all the matings on a lek is often dead by the next year. he has only a 25% chance of surviving. So the effort he has put in, and they also notice something interesting, which is that you can be a successful top male when you're 3 or 4 or 5, and they even had one who didn't manage till he was 6. Generally not when you're 2 or 1. But the year in which you do it is your year of maximum effort. It's when you're in your best condition and you're dead within a year on the whole. So it's like, you're working out when to accelerate into the front of the pack, as it were. Am I in good enough condition to really go for it this year? Seems to be almost what they're doing. I tell the story in the book, and the book is dedicated to one bird called wonky tail. And we first noticed wonky tail about 5 years ago. He's got some spinal deformity, which means that his tail is at that angle instead of that angle. And he seemed fine otherwise. And there he was the next year, slightly closer to the center of the lek. And then the year after, he was about the same place. He's very close to the middle, but he's not the top male. He's not getting any matings. And then one day he did get one mating. I was thrilled. I was there and saw it. And then last year I thought, well, will he be back? And sure enough, he was back. But he was a shadow of his former self. He displayed much less often. He looked pretty scruffy. His red eyebrows were much smaller than usual. And by the end of the season, I think he disappeared. I didn't see him the last few times I went. So I'm pretty sure he's not going to be back when I go there next month. He probably, as I say, he did get one mating in his life. But his neighbor and friend Black Spot got about a dozen in 1 year.
The Finns, with all their data.
Yes.
If they, quote, understand this in any dimension, which I'm not sure, and maybe I missed this in the book, I apologize, or forgotten it, they should be able to predict. If I gave them 20 birds and I said, here you go, you don't get to see them on the lek, you don't get to see, maybe you could see them dance a little bit, I guess, because you need that. But actually a better way to say it is, here's 20 birds, it's October, I'm going to let you watch them for months. And on that 4-day period when the females show up, you tell me who the top bird's going to be, because you've got their wing dimension and the color, brightness of their blue, and you can use all kinds of fancy science to measure the iridescence, et cetera, and how often, how long, how blah, blah, blah. Can they predict?
Actually, that's a really good question. I wish I'd asked Carl Salisbury that, who's the guy who runs the study these days. It was started by an old friend of mine, Rano Alatalo, but he's unfortunately died. Judging from their papers, they can statistically be more likely to predict, but not with any tremendous precision. And
they can backcast. They can't probably forecast. They're two really different things.
Certainly. Yeah, that's true. That's true. Yeah.
And so facing that and hearing this extraordinary story, which is really not a credible story, Matt, but I know you. I think you're a person of integrity. And I don't think that the videos on YouTube, which I encourage listeners and viewers to check out, because they're quite extraordinary. I think this really does happen, but it is rather peculiar. And it's hard to understand, and I know this is what drove you to write this book. Let me make one other observation. When I look at animals at the zoo or members of a single species, I can't tell them apart. Mm-hmm. I assume they're co-species, their brethren can, their sisters and brothers. Yeah. Because, that's so-and-so.
Yeah.
But unlike humans, where it appears to be an enormous variation in size, height, nose length, ear size, teeth straightness, thickness of lip, thickness of eyebrow, hair color. Like, we're really different from each other. At least it seems that way to me. Tell me two things. Do animals, do they see each other as differently, do you think, as we do? And if not, those 20 birds do look a lot alike. Mm-hmm. Like you say, there's really, that black spot just dominates is shocking. Mm-hmm. He's not, to pick a really bad example. Well, I'm not even going to say it. Okay, go ahead.
Well, you're going to say he's not Brad Pitt or something.
Yeah, I had a worse example. Go ahead. I'll tell you after the recording's over.
Well, clearly they can distinguish individuals better than we can. I'm sure everyone's better at distinguishing individuals in their own species. And of course, it's a bit of a cliche that human beings are better at distinguishing individuals in their own races, actually, within species. So that's a similar point. And I think, an animal that lives to 70 and indulges in a lot of culture, or 80, is bound to have a degree more differentiation. And an animal that has been racially diverging in different parts of the world and then mixing again is going to have more divergence in more variation in skin color, hair pattern, and so on. But yes, I think we are a very variable species. In other words, but yes, I think we underestimate the degree to which other species can see individual variation. But I come back to the point that this bird in particular, and nearly all the other lekking birds, or indeed other kinds of brightly colored birds that you want to look at, the males don't look that different, and yet the females are very, very choosy. In human beings, my wife settled for me. She didn't hold out for Brad Pitt. In black grouse, she could have done, to put it at its bluntest. Now, I do want to bring another species in here that I write a chapter about. It's called The Riddle of the Ruff, the chapter. And there's one species of bird. It's called the ruff, and it's very peculiar. I'm beginning to think it arrived here from Mars, actually. It's so odd. Most of the year it looks pretty ordinary. It's just a sandpiper, and it lives on marshes. But in the spring, the males grow a plume of feathers around the neck and around the top of the head, which are different colors. And when I say different, I really, really mean different. No two males look even remotely alike. They can be brown, reddish, gray, white, black, bluish. They can be patterned, plain, checked, striped. It's as if everyone has gotten instructions to come to the party wearing a different outfit. And there's no other bird like this. Every other bird, there are examples of birds where individuals do look significantly different from each other, but on a sort of continuum, not in this sort of literally individual and distinctive way. And it's a lekking bird where the males gather together. But unlike the black grouse, the females take care to mate with several different males on each lek. And there are, as well as the multiple colors, there is a distinction between the ones that have whitish ruffs and the ones that have dark ruffs. The whitish ruffs don't hold territories on the lek. They wander anywhere, and they're tolerated by the dark-ruffed ones who hold territories because they're attractive to females, and the females like them. So the male says, come and display my territory, and then when she's ready to mate, we'll have a competition, and I'll get there first, but at least you've helped me attract them. That seems to be what's going on. And then, only 20 years ago, even though this species has been known for centuries, a Dutch potato farmer spotted something else, which is that some of the birds they thought were females are actually too big to be females. They're actually males that look like females. About 18% are the white-ruffed ones, and about 1% are these female mimics known as faders, Dutch for father. These deceive the ordinary males. The males think, oh, that's a female. And in fact, it's not. And it suddenly pounces on one of the females and mates with it. And the fader's testicles are twice as big in proportion to the body as the ordinary male's ones, which explains how the fader mutation, which is similar to the white mutation, survives, because it's a lethal mutation. It kills the individual if you get it from both your parents. You're okay if you get it from one parent and not the other. But, this is a mutation that's lethal in the so-called homozygous form, so it's bound to die out, isn't it? Well, it hasn't died out. And that's probably because these testicles are so enormous in both the white and the fader forms, that in terms of sperm competition, they actually succeed more often than not. Just when I thought I'd figured out everything about sexual selection, I spent a few days watching these roughs and reading up the literature on them, and I'm back to square one. I don't know what's going on. It's baffling and fascinating.
I'm going to go back to the grouse for a minute, because there's one other thing I wanted to ask you about. When the females show up, do they show up at once or seriatim?
Mostly together at once.
Mostly.
So you tend to see 2 or 3 females arriving together, and maybe then another 2 or 3, and suddenly you've got 6 or 8 on the lek wandering around, and they have a little bit of interaction between them. They tend to, one female will say, "Get off! I'm flirting here at the moment. You go away." She flares her tail and chases the other one away, but not to the same degree as the males. They're just not as if they have territories or anything. So there's competition between the females going on. And maybe that's because, while you want to copy what others are doing, you don't necessarily want others to copy what... No, that doesn't really make sense, but do you see what I mean?
Yeah. You think you want to get your own access to the black spot and make sure that you don't get closed out. But what I'm thinking is, and you allude to this briefly, and I'm surprised you didn't give it more coverage. The fact that the offspring are half brothers, many of them, or at least cousins, and that they therefore act in a fairly, you call them chums, and you detail some of the ways that they behave almost cooperatively as a group. In a way, the lek is the family, and the fact that the fact that many of them don't get to procreate is maybe not so important,
right?
And what I would hone in on, if this were my area, is I would want to take those 8 or 10 females and bag them, put them off to the side, and I'd release one at a time. And I wonder if they'd all go to black spot. I wonder how much of it is pick the same guy, because then we'll have a shared genetic community and we'll protect each other in all kinds of ways over the next 1,000 generations.
Right. Well, and this is essentially the kin selection theory, and that's the reason why in an ant colony or a bee colony, ants are very happy to rear their nephews and nieces rather than their children via the queen, because they're all so closely related that it's an effective way of reproducing. The Finns don't think this is what's happening with black grouse. They've measured the genetic relatedness of the males on the lek and say that, look, they're not really, I exaggerated when I said they're all half brothers and brothers, because remember, it's a different male each year that gets to father them, and there are males of different ages on the lek. So when you look at that, yes, they're slightly more closely related than randomly, but it's not so close that it really makes sense for you to give up reproducing because your brother's going to do it for you. You've got half uncles all over the place and half nephews on the leg. Well, that's not very close. That's, I don't know, it's a 16th or something, isn't it, of genetically?
Yeah,
so
true.
it's not. It doesn't seem to work as an explanation. But you mentioned the experiment of releasing females one by one to see which one they chose. And this has been tried in a number of species. It was tried in sage grouse by Mark Boyce, who's an old friend of mine who's done these studies in Wyoming, to see if females chose the same male independently, even when they can't see each other, and then to see whether it made a difference, whether they could see each other. And those experiments they're not terribly clear in their outcome. Yes, they do seem to end up going to the same male on the whole. And what they did was they put a female in a cage with 6 sides to it, and there's a male caged on each side of the female. The problem is this doesn't mimic a lek very well, it's not really clear what's going on. And yes, in one study there did seem to be some copying, in another study there didn't seem to be some copying by the females. So we don't really know the answer to that question. And there's one series of experiments I described where putting a stuffed dead female in a male's territory to see if that made that male more attractive to other females. Well, the problem is when you do that, the male in whose territory you've put it in simply mates with the stuffed bird incessantly for up to an hour.
No comment. But let's move on to human beings, because the last part of the book, you have some provocative things to say about human beings, and then we'll come back to the birds to sum things up. Talk about the hand axe. Many people have seen a chiseled hand axe from ancient times. It's a teardrop, roughly the size that would fit in your hand, and it's been chiseled's not the right word, but it's been formed as a tool. And we have many of these. And you suggest in the book, rather provocatively, that this could be the Ferrari or the Rolex or the Porsche of our forebears. Explain that idea.
Yes. Well, this object called an Australian hand axe is made to a pretty standard design for something like 1 million years. And it's made almost all over the old world in this form. And that's very odd. We think of technologies as changing all the time. You don't use the same phone as you did 10 years ago, let alone 1 million years ago. And you don't, in a population that's living all over the world, you'd expect it to vary from place to place. And to explain this very monotonous, very monolithic appearance, it's not completely without variation, but it's a surprisingly similar technology. Anthropologists and archaeologists have generally said, well, look, they hadn't invented innovation yet. They'd invented technology, but not innovation. And they had a culture of conformity where everybody agreed to stick to the same design. Well, maybe.
Yeah, could be.
But a parallel is to think about birds' nests and to say, a robin, a Eurasian robin in Eastern Russia or Western Ireland builds a nest that looks pretty well identical. And a thrush builds a nest that looks completely different. It lines it with mud, whereas the robin lines its nest with hair, and the greenfinch lines its nest with feathers. Okay, now these habits are instincts. Nobody's pretending that that's got to be learned by every generation of robins. They have an instinct to seek out animal fur to line their nest with, and the thrush has an instinct to seek out mud to line its nest with. So maybe the Australian hand axe was an instinct. It was an animal that had an instinctive drive to create a thing, to the same design, and it just couldn't help itself. Every morning it woke up thinking, I must make a hand axe to this design. It's a hard idea for us to get our head around. But remember, we're talking about Homo erectus, not Homo sapiens. We're talking about a creature with a much smaller brain and a very different, a much simpler culture. So that's possible. And if you accept that, you can then go one further. And this isn't my idea. This is Marek Cohn and Steve Mython, anthropologist and archaeologist. They said, well, maybe this thing, which we don't really know what it was used for. I mean, it could have been a useful way of slicing up woolly rhinoceros carcasses when you'd killed one. But why make it sharp all the way around? Why make it symmetrical? Why not just have one side like you do on a knife? They seem to have gone to great trouble to make these things very symmetrical. Maybe it's sexually selected, not naturally selected. And what I mean by that is maybe the way in which you attracted a mate to mate with you was by showing your skill in making an Australian hand axe, and how well that instinct was being expressed. And okay, I don't know whether that's right or wrong. It doesn't sound very persuasive when I put it that way. But the point is really to drive home that we are wrong to assume that the default explanation is going to be a natural selection one, when we know that sexual selection is a huge force in evolution in many other species. Why are we assuming that sexual selection needs a special explanation when natural selection is the default, is the one that if we can't think of any other explanation, it must be this must have helped them survive. Why survive? Why not seduce, for example? And once you start putting that idea in your head, you start to say, look, have we been neglecting sexual selection in human beings as a motivating force for how we came to change over time? Did things like wit and humor and music and dance and imagination help us survive or help us seduce? And why are we tending to assume that it must have been to survive? Why are we neglecting the investigation of the possibility that a lot of these features developed in us as seduction devices rather than survival devices? Because we know that wit and humor and musical skill and other things are sexually significant in human beings.
Yeah, which brings us full circle, really, to the opening of our conversation. When we're thinking about the transition from Homo erectus to Homo sapien, and, let's just pick the Flintstones, okay, because, it's a modern Stone Age family. When Fred and Wilma are out on their first date, and Fred says something witty, and Wilma thinks, it's going to be pleasant to be around this guy for the next, well, not 50 years, because we'll probably be dead by 40, but eaten by a stegosaurus or whatever, T-Rex. It's hard to believe that I wouldn't focus on whether he's big and strong. Barney Rubble should not get a mate. I'm sorry. I don't care how funny he is. He's short and unlikely to provide for the offspring. So the challenge here, and the reason this is such a provocative book, is you diligently and powerfully and eloquently remind us that reproduction matters and sexual selection matters. But it's hard. Maybe it's because of the way we were socialized in studying biology or the culture around us. I think we're all pretty aware of how important sex is and how much we care about who mates with us, who doesn't, and who pairs with us. So Freud was onto something, no doubt. But the idea that through the entire history of human evolution, that the ability to say, have a nice voice would charm a woman from her father's cave, parents' cave, seems hard. It's hard for me. I have trouble with it. And so when I come to the birds, I have the same challenge. How would that work? That appreciation of humor, beauty, grace, fill in the blank, if it isn't obviously related to fitness. So I'm intrigued by your attempt to rebalance this, and it spawned many, many interesting thoughts along the way. But the story is still really incomplete. And I'll just finish with this and let you respond. One of the great things about this book is it's an incredible portrait of a scientific puzzle that is not unimportant. It's tempting to say, well, birds, a black grouse, who cares if we don't really understand the black grouse? It's troubling. It's because birds are not a small thing. We think we understand a lot about the natural world. This puzzle remains. You argue on behalf of various parts of the various answers, but it's fascinating that we haven't solved this yet. And I expected at the end of the book to get a punchline. And the punchline is, it's a bit of a mystery. That's my punchline. React to that. Am I being fair to you and to the received science?
No, I think that's very, very fair. And for me, that's what science is. It's the exploration of mysteries, not the cataloguing of facts. The science is much less interesting once it's settled. Half the fun, what did cause the ice ages to oscillate the way they did? What did start the Big Bang? It's the things we don't know that really get my juices flowing, as it were, not the things we do know. You put them on a shelf and feed them to the students. And so this is interesting, this topic, because it's not settled, it's not resolved. I'm in a relatively minority position in thinking that the Darwin-Fisher explanation is generally better than the Wallace version, that it's in the end really just a way of picking good offspring. I think it's a way of picking sexy offspring, which explains why it goes off in arbitrary directions. I think both effects are at play, but the Fisher one has tended to dominate in colourful birds. I think we're underestimating its importance in other species, including human beings, and we need to find a way to understand that. But there is a nihilism in it, which you've zeroed in on, in that, I'm saying there is no rhyme and reason to the particular pattern of a peacock's tail, and there may be no rhyme and reason to the ability to sing songs and write poetry and tell jokes, because those might be just seduction devices which are justified by their ability to seduce. So they're circular in their meaning, and it's a mistake to think of them as helping ancestors conquer the world or survive or something like that. Do I think that's the whole answer of entirety of human evolution? Of course not. There's clearly natural selection involved too. And clearly when a man or a woman selects a long-term mate in our species, they are looking for all sorts of things like compatibility and kindness and maybe strength and maybe health and maybe youth and all these things, which are perfectly sensible things to look for in a mate in terms of a pair bond that's going to persist and produce healthy children. And that's all very rhyme and reason-y. But we're not just rhyme and reason creatures, are we? We are swayed by beauty, whether it's the beauty of a beautiful woman for a man, or the beauty of the song of a pop star for a woman, or or vice versa. I mean, I'm not trying to be sexist here. And to try and understand that without getting your head around this extraordinary, mysterious, and underappreciated phenomenon of sexual selection with its implications is wrong. And so I come back to a point I make very early in the book, which is that I'm not sure, even to this day, that I have fully appreciated the implications of this idea that started with Darwin and has been developing since.
My guest today has been Matt Ridley. Matt, thanks for being part of EconTalk.
Thank you very much, Ross. It's been really enjoyable to be allowed to go off in all directions.
This is EconTalk, part of the Library of Economics and Liberty. For more EconTalk, go to econtalk.org, where you can also comment on today's podcast and find links and readings related to today's conversation. The sound engineer for EconTalk is Rich Goyette. I'm your host, Russ Roberts. Thanks for listening. Talk to you on Monday.